have an excess amount of oxygen to react with an organic substance to produce water and carbon dioxide. Now, carbon dioxide will be the main product that will occur if the reaction is complete combustion reaction. The beautiful aspect of everything is if the amount of oxygen in that combustion process or reaction is limited or is in a short supply of oxygen, then there will be certain elements like carbon monoxide in a reaction together with a carbon dioxide. And such reaction is incomplete combustion. Okay, now let's demonstrate what we are talking about. The complete combustion reaction and incomplete or limited amount of oxygen, right? So now let's see. So if we have an element like CXHY, oxygen plus oxygen will definitely produce CO2 plus water. And this we call combustion reaction. This is combustion reaction. Because over here we have excess amount of oxygen, okay, reacting with that organic compound, and that gives us carbon dioxide plus water. Now, the difficult aspect of it is when the amount of oxygen is limited. You see, when amount of oxygen is limited, for instance, if you have a compound C, XHYOH or something, reacting with a limited amount of oxygen, then the production will be carbon monoxide plus carbon dioxide. If we have CXHY, okay, O2 reacting with limited amount of oxygen, we are going to get carbon monoxide plus CO2. And this is not complete reaction. Okay, so as we can see, we have complete combustion reaction and two, incomplete combustion reaction. Now, complete reaction will be as a result of excess oxygen. You see, then we have a lot of oxygen in what usage, and that we will be able to produce water and carbon dioxide. But in other way round, if the amount of oxygen in the reaction is less, then the reaction will tend to be incomplete. And the incomplete combustion reaction will give us carbon monoxide. See, so incomplete combustion reaction will produce carbon monoxide and carbon dioxide, which such a yield is called incomplete combustion reaction. Now let's see when, we can balance equations which are completely combustion reaction. Let's look at this. If we have a compound, say methane, which is CH4, reacting with oxygen. Okay, we know our product will be water plus carbon dioxide. So in such reaction, how do we balance it? If you look at the left-hand side, and there's a right-hand side, you can see that we have one carbon here and one carbon here. Okay, but hydrogen, we have 4, as you can see over here. You see, the hydrogen, we have 4 over here. The hydrogen here is 2. Meaning, if we put 2 here, then we have 4 hydrogens. Okay, so look at the left, we have 4 hydrogens on the left and 4 hydrogens. Because the 2 multiplied by this 2 will give us 4. We have this 2 multiplying by this oxygen will give us 2 oxygen. So 2 oxygen here and plus 2 oxygen here, we have 4 oxygens. Okay, left hand side here, our oxygen is only 2. So that means we need to put 2 here to balance it. And this makes it a complete combustion reaction. Now, isn't that beautiful? Now let's look at another combustion reaction, because from methane we go to ethane. C2 ethane. That one will be C2 H2N plus 2, and that will be 8 plus oxygen, and that will give us also water plus carbon dioxide, because we have excessive amount of oxygen, and this excessive amount of oxygen will help us to produce water and carbon dioxide. Okay, how do we balance this reaction? Okay, now when we have, as we did to the first one, if we look at this place, we have 2 carbons. And over here, we have only 1 carbon. You see, meaning if I put 2 here, I have 2 CO2, and the carbon here is 2. Then here, I have my hydrogen here to be 8. Meaning if I put 4 here, the hydrogen will be 8 on the right-hand side too. But then the oxygen here will be, this oxygen in this component will be 4. Then the oxygen over here also 2 times that will be 4. So that means we have 8 oxygen. You see? Yeah? So we have 8. So what do? C2H6. Now, the compound is C, let's see, what are we are, CnH2n plus 2. So C2 will be H6. So this is supposed to be 6. You see, that is why I always say you have to check what you are doing. Because this one, so we take everything off here, like that. Then this is H6. That is methane, H6. Okay. Now, let's look at it critically. Okay, right now, if we look at it this way, then it means our hydrogen on the right-hand side will be 6. Good. So our hydrogen is 6 here. And hydrogen is 2 here. So we rather put 3 in front of the hydrogen on the right-hand side. And that one will give us 6. Now, if we do that, what about the carbon? Carbon here is 2. Friends, so if we put 2 here, then we have balanced the carbons on the right-hand side. Now, the carbon on the right-hand side here. So now we have 2 on the right-hand side, and we have 2 here. Hydrogen is also 6. Hydrogen is 6 over here. But let's look at oxygen. The oxygen over here is 1 plus 2, which is 3. Okay? That is not helping us. So what do? We need to balance it. Okay? Because here, the oxygen here is what? 3. There's a 3 plus 2. That will give us 5. Yeah, 3 oxygens and 4. So 3 plus 4 will give us 7. Okay, now let's look at it. So here we have oxygen, 3 here, plus oxygen here. This will multiply that. That will be 4. That will give us 7. Meaning we got to put 7 over 2 here to cancel the oxygen here. So in effect, the equation will now look at it this way. When we multiply both sides of this through by 2, then we are going to get 2, C2H6 plus 7O2. And this will give us 6 water and 4 carbon dioxide. And that is the complete reaction. Okay, now let's look at propane. Propane. So propane is the next element. Propane. So knowing CnH2n plus 2, and being 3, your propane will be C3H8 as the compound. So C3H8 plus oxygen should give us CO2 plus water. Now we have to balance it to get a complete reaction. How do we balance it? Okay, propane now is the same way we did earlier. And when we look at the left-hand side, we have 3 carbons here. Here, our carbon here is 1. Okay, so what do? Let's look at our hydrogen. Hydrogen here is 8, and hydrogen here is 2. So when we put 4 here, we have balanced the hydrogen on the right-hand side. So then the hydrogen on the right-hand side becomes 8, and the one on the left-hand side also becomes 8. What about the oxygen? The oxygen, because of the introduction of the 4 over here, we multiplied oxygen to be 4. So you see we have oxygen 4 here, plus oxygen 2 here, and that gives us 6 oxygens. So what do we do to balance it completely? our carbon, as you can see, here carbon is 3, so we got to put 3 here as well. If you put carbon 3 over here, that means the oxygen over here will become 3 times 2. That is 6. You see? Now, if it's 6, then this changes. Okay? If the oxygen is 6 here, then this plus 4 times 1 here, that will be plus 4. So our oxygen will be 10 in total. Meaning we need to put 5 here to have this equation balanced. Is it not interesting? Very, very interesting. Very interesting. Now, in the same way, as we keep going, that is how it's going to be. If we look at the next element, which will be butane, the 4, because N is equals to 4, we have CnH2n plus 2. So, definitely, when we substitute the 4, we are going to get C4H10. That's butane. So there's reactant with oxygen. So C4H8 plus oxygen. Definitely we're going to produce the same, that, and water. So what do? The same procedure. Now, here we have our carbon to be 4. Okay, and the carbon, so meaning if that is the case, we can put 4 here so that we balance the carbons. So the carbon here becomes 4 here, and here also becomes 4. But when the carbon becomes 4, it affects this oxygen here, and the oxygen will be 8. Okay, now, if that is the case, hydrogen here, we have hydrogen here to be 4. Okay, hydrogen here to be 4. Butane, no, sorry, 10. That is 10 that we have. Okay, so 10. So that will be 1, 0. So if that is the case, as we saw earlier, then that we are going to have C4H10. What do? The hydrogen here, as we can see on the left, is also 2. So let's do something. So there's a plus that. If hydrogen here is 10, then hydrogen on the right hand side must also be 10. So let's put 5 over here and see. So we put 5, and completely our hydrogen has become 10. So we have a 10 here. Oxygen, because we put 4 in front of the carbon, this one becomes 8 plus 5, which is 13. If that is the case, we should have the same on the left. So it means we have to put 13 in front of this oxygen divided by 2 so that this will cancel that. So the equation now will look this way. C4H10 plus 13 over 2 oxygen. That gives us 4CO2 plus 5H2O. Okay, so that's the complete combustion reaction that we have. But we haven't finished. Why is it so? Because we don't want a fraction, so we have to multiply 2 by 2. So in effect, the equation will become C2 multiplied by C4H10 plus 13 oxygen. That gives us 2 multiplied by that 8 CO2, and there's a 10 H20. So if you look at the left hand side, you see that if you multiply 2 by 10 here, we are going to get 20. So you see the hydrogen is 20. Over here too, 10 by 2, 20. So the equation is completely balanced. Okay, now look at it from this way. A certain student asked me a question that, where's the question? I'm looking for it. Where's the question? Okay. That is the question. That if we have another reaction which can be equally combustion reaction, how would we balance it? Okay, if we have a compound like methanol or something like that, how would you go about it? And I told him it's the same procedure that you have to let it react, let it go. So let's see what he was asking. So for instance, if I have ethanol, you have ethanol, which is C2H5OH plus oxygen, excessive amount of oxygen will also give us carbon dioxide plus water. Okay, so now let's see, how do we balance this one? Okay, so here it's going to be the same, because if you look at it, we have 2 carbon here and we have 1 carbon here. So when we put 2 here, you see we have balanced the carbon. Okay, the oxygen here becomes 4 plus that. So I'll put 3 here to balance the hydrogen. Then we see we have hydrogen H, we have 5 plus 1 here. That makes it 6. Then here, hydrogen becomes 6. But it affects the oxygen. So the oxygen becomes 3 plus 4. That is 7. Have you seen it? So ethanol. Now if you want to put 3 in front here, we are going to get our oxygen here to be 6. Okay? Then when we add this one, we'll make it 7. So you see 6, that, and this will be 2 to cancel this one over here. So now let's see. If we said so, then our hydrogen here will become what? 6. And the one here, the hydrogen here, become 5 plus 1, 6. We have oxygen here. That makes it like that. Okay? So when we balance the equation, you see that we have, on the left hand side, we have oxygen to be 6. Yeah? Oxygen here to be 6. Okay? Because this will cancel this. So 3 plus that 1 will make it 6. And here will be 6. So we have 3, which makes this one. Yeah? 3, that makes this one 3. Then we have here 4, that makes the oxygen 4. So we have 7 on the right. Now, if we have 7 on the right, then we don't need the fraction. You see, so most often than not, students will do try and error to balance the equation. Now let's look at it very carefully. Let's look at this one. So this reaction, as you can see, we have it the way it's supposed to be. So now, if you look at it, on the left-hand side, we have oxygen to be 6 plus the oxygen in between the ethanol, that makes it 7. Okay? Then on the right-hand side, we have 4 plus 3, that is 7. Okay? Then, if you look at it again, when we're looking about the hydrogens are 6 on both sides. So the equation is completely balanced. Now, somebody will say, all this procedure is there, if we look at it very carefully, we see that from the methane, ethane, propane, butane goes together. And mathematically, if you look at it very carefully, you see that it can coin a certain formula that will help us to be able to generate this one. Okay, so let's see. If we have this to be the general formula, so when we say Cn, H2n plus 2 plus into bracket 3n plus 1 over 2 oxygen, and this gives us n plus 1 into bracket water plus n CO2. Let's see if this will help us to be able to get the formula of combustion reaction without difficulty. So let's say if n is equals to 1, then by substitution we are going to get CH4 plus 3, 1 plus 1 all over 2 oxygen. This will be 1 plus 1 into bracket water, and this will be 1 times CO2. So when we do that, we're going to get CH4 plus 3 over 2 oxygen, and this will be 2 water plus CO2. Let's see whether it balances the equation. Okay, it does balance the equation because this will cancel this and that. So oxygen will be 6. This is 2 times what they call oxygen here is 2, and this, the oxygen here is also 2. You see, this is 3 times 1, this will be 4 over 2. Let's do our calculation very well. So this will be 4 over 2, 4 over 2. So this will be CH4 plus 2 oxygen and 2 water plus CO2. And you see that the equation is balanced. Because we have 4 hydrogen on the left, 4 hydrogen on the right. We have 2 oxygen in water and 2 oxygen in carbon dioxide. That balances the equation. So let's see. If that is true, let's try when n is equals to 2. When n is equals to 2, you see, as the formula goes, it's going to be what? C2H. So 2 times that will be 6 plus 3n. So this will be 2 into 2 plus 1 all over 2 oxygen. Then we have 2 plus 1 water plus 2 carbon dioxide. Now let's see what if it works. So this implies C2H6 plus 5 over 2 oxygen, and that gives us 3 water and 2 CO2. Does it balance the equation? It does, because over here we have 2 carbon dioxide on the left, 2 carbon dioxide on the right from the carbon dioxide, 2 hydrogen, we have 6. Here we have hydrogen 6. Now let's look at oxygen. Oxygen is 2 times 2 plus 1, 5. So now after that, we multiply through by 2, and the equation becomes C2H6 plus 5 oxygen. This gives us 6 water plus 4 carbon dioxide. So this formula holds. So then we have to bear in mind that this is the general formula. that will help us all the time when we are balancing. When we are balancing combustion reaction. So this is the reaction that will help us a lot. Okay, we can also try. Somebody's asking us to try it with a propane and see whether it's true. Okay, so propane is N is equals to 3. So CnH2n plus 2, 3n plus 1 over 2 oxygen, n plus 1 water, plus n CO2. So n equals to 3, we have C3H6 plus 3 times 3 9, so 10. 9, okay, somebody said I should substitute it for them to see. So we go back here, we have 3 into 3 plus 1 all over 2 into bracket oxygen, 3 plus 1 water plus 3 CO2. So we have C3H8, and this 3 times 3 is 9, 9 plus 1 is 10, and that will be 5 oxygen, and that will give us 3 water plus 3 CO2. Now let's see whether it's true. We have 3 oxygens here plus 6 oxygen, so that would be 9 oxygen. Yeah, so 3 n plus 1 water, and that is so this is n plus 1, which n is 3, not 4. N is 3. So we have to put 3 here. So n plus 1, 3 plus 1 here will be 4. Okay. So 4 water and the 3 carbon dioxide. So let's see whether everything is balanced. So here we have carbon to be 3, carbon here is also 3. We have hydrogen here to be 8, hydrogen here 4 times 2 is 8, and we have oxygen here to be 10, 5 times 2, and oxygen here, this is 4 times 1, so that is 4 oxygen plus 3 times 2 over here, which is 6 oxygen. So together give us 10. All right, friends, that is where we'll finish with our combustion reaction. So you can take time and go through all the reactions that we have discussed. Now you know if it's oxygen that is reacting with a compound, organic compound, S in SX, then we'll be able to have complete combustion reaction. You see, if the amount of oxygen is limited, then we are going to produce monoxide and carbon dioxide. So that's more reason why you need excessive amount of oxygen to produce a proper combustion reaction. Okay, as you've seen, now we're able to balance the reaction. You see, using our mental, capacity, and then later on, after some time, we realize that it follows a certain series when you look at it in a mathematical point of view, and this gives us this equation, as you can see over here.